So I hope you all written all the 8 points of kinetic theory of gases. So just most important points is please remember that point number 6, 7, and 8. So let it be just within 2 minutes. We'll wind up like all the 8 properties. If you have written really in the classwork, you can proceed. I won't write. I just speak. So what is the importance of a dual thing? So when any object, like we all knows that this is all the postulates actually. So if you have been keep reading, this is one of the important topic for IIT mains, JEE mains, and as well as NEET. So kinetic theory of gases. So if you have been taken at, so there is a several postulates which has been assumed by mainly two scientists worked in this. Who is the scientist? Everybody? Yes, please. Kinetic theory of gases. There is a two scientists who have been done their work in this. Any one of you? Boltzmann and another one is what? Two scientists, even I told you, kinetic theory of gases.
Charles.
Maxwell. Maxwell and Boltzmann is the two scientists who has been done the major contribution in kinetic theory of gases. And remember, these postulates are assumed only 100% these are valid only for ideal gases. So if you have been taken for real gases, it is not applicable in always. So now, if you see the major postulates here, so you can see first one, molecules of same gas are identical in all the respects, like mass, shape, size. Suppose if I take hydrogen gas, all the hydrogen atoms are same shape, same size, same mass. If I take oxygen, all oxygen molecules are same shape, same size, and same mass. So that is the first postulates of kinetic theory of gases. Am I right, everybody? Is it right, guys? Please respond. Next, second postulate. Molecules are constantly in random motion along the straight lines. So that is the second one. So here, along the straight line means it can travel in three different directions. Always a gases can go in three different directions. So let us assume it is moving with the velocity u. So means in the sense of it can travel in three different directions. What is the three different directions? Everybody. It can travel with the same velocity in x direction. It can travel with the same velocity in y direction. It can travel same velocity in what direction? Please respond. Z direction. So we all knows that. So average velocity is equals to x direction I cap plus y, the velocity of y direction j cap plus velocity of z direction k cap. Vectors, remember everybody? So we all knows it can travel. See that, for example, this gas particle is moving with the velocity u in x direction. In y direction also it can go with the same velocity, but in y direction. Z direction also it can go with the same velocity, z direction. Means in the sense of what? Ux is equals to uy is equals to uz, means there will be always it can go with the same velocity in any direction, whatever it can goes. So that's what, if you apply the square root in both the sides, what will happen, everybody? Mod u is equals to root over u velocity in x, velocity square of velocity in x direction plus square of velocity in y direction plus square of velocity in z direction. So I'll replace ux equals to uy, uy equals to uz. So I'll get mod u is equals to, we will get it in place of x, y and z, I'll write ux. So we'll get what? Ux 3ux square. Am I right, guys? Please respond. So average velocity u is equals to 3ux square. This is what is the velocity of a particle. So this is what I think point number 2, you have been done this point. Am I right, Mr. Rudresh, Pradosh? All of you might be remember that. Please respond, guys.
Yes, sir.
Yes. So then third point, all the collisions of a gas molecules among themselves and walls of container are, what is the nature? Third point, they all are in what nature, everybody? Elastic in nature. Elastic in nature, and you might be notice it. So I have written with no loss. What is a no loss? Anybody? That is a point number 3. There is a no loss I have written. Any one of you? Please respond. So imagine that if this is the wall of a container, have I written or not? At least is there or not something I have written no loss? What is no loss?
Maximum kinetic energy.
Maximum, not momentum.
Momentum kinetic.
Momentum and kinetic energy. No loss. For example, imagine if there is a gas particle who is traveling with x velocity, came and collide this wall. This is the wall of the container. Wall of container. Clear, everybody? Or it may collide with some other particle who is there. It may collide with anything. but it will come with the same velocity. Same velocity, it will be returned back. That is what we used to say. It is elastic in nature and loss of momentum. No loss of momentum. What is the momentum formula? Anybody? Momentum P is equals to mass into velocity. No loss of momentum or no loss of what? Everybody? No loss of kinetic energy.
Kinetic energy.
Kinetic
Those,
energy.
that is the meaning of the third point. Understand, initially it is not maximum kinetic energy, momentum. Please modify it if you have been done. We have importance of this point also today. Next, the pressure of a gas is due to collision of molecules with the walls of container. Why inside a gas is exerting pressure? Because of collision. Because of collision with the walls of container. So that is only caused to increase the pressure inside the what? Container. So here pressure inside the container is depends on number of collisions of molecules per unit area. So that is what I hope you all written, but once again I'm writing per unit area. How many number of collisions makes? That is the pressure of a given gas. That is what you have to remember. Hope you all understand, guys. Please respond. Next, most important thing is this one. Kinetic energy of a gas is only depends on temperature. Please remember that. Only depends on temperature, not relay or depends on what, guys? Not depends on nature of the gas. So hydrogen, oxygen, helium, adi sambandhame illa. The kinetic energy of the particles is only directly proportional to temperature. Today we are having importance of this also. Then point number 6, 7, 8. I hope you already studied. Please respond, guys. Everybody. Have you all studied? 6 and 7 points. 6 and 7 are most important points for ideal gas. Okay. So, but these 6 and 7th point is not applicable. Not applicable for what? Everybody. Not applicable for what? For real gases. So that is why kinetic theory of gases will study for ideal gases. So the point number 6 and 7. What is the point number 6, everybody? The volume occupied by a gas molecule is negligible when compared to the volume of a gas. When compared to the volume of a gas. Last class we solved one numerical. Do you all remember, everybody? Ratio? Volume ratios. Please say yes or no. That
Yes,
is
sir.
what. So volume occupied by a gas molecule is negligible when compared to volume of a gas. So that is what you have to remember. Next, no intermolecular force of attraction among the molecules in where? Ideal gas. But it is not possible in the real gas cases. They are saying no intermolecular forces among the gases. It is impossible. There is no gas existed till now. So that is what, but of course, we'll make it. Okay, everybody. So this is what you have to remember it. Anybody having any doubt, please let me know, or else we'll proceed from here. Is it okay, guys? Everybody?
Yes, sir.
Yes. So now, kinetic gas equation. Today I'm going to teach you that only the derivation. Anybody knows the derivation of kinetic gas equation? Mr. Rudresh, Kadosh, have you all learned, Laksha? Anybody? Mr. Narayan? One response. Have you learned kinetic gas equation? Yes or no? At least
Yes, sir.
equation. Anybody? What is the equation? Kinetic gas equation? Anybody? Kinetic gas equation, please. Already you have written classwork. I send you also. What is the kinetic gas equation, please? PV is equals to, nobody studied 1 by 3 into M into N
MB.
into, okay, URMS square. So what is URMS, everybody? Root mean square of mean square velocity. Mean square velocity of molecules. So that is what we used to call it as a UR square. So here P means pressure, V means volume, M means mass of, this is very important, mass of one molecule of gas. mass of one molecule of gas. N means number of molecules, not moles. Number of molecules. U means root means square velocity of molecules. Means average will take it. That is what you have to remember. Now somebody called Manya and Samya. Have you all remember everybody? Please let me know, guys. Respond, guys. Love you. Yes? Yeah.
Yes, sir.
Now you might be remember in some chapter, I did not exactly remember the concept, but you might be remember if there is a different particles in a system. So let me take velocity is u1, this velocity is u2, this velocity is u3, this velocity is u4. Like that, un number of particles is there. So we all knows that average velocity we have done that, which is equals to what is that? Remember, Dresh, we have done that. So u1 square plus u2 square plus u3 square plus and so on un square divided by number of particles. So which will give you the average root means square velocity. I hope you all remember that we might be done multiplying with the n divided by n like that. Today also we are going to do that. Please respond, guys. Anybody? Rotational dynamics, if my guess is true. Is it right? Yes. Not remembering, also you have to remember. So now we are going to derive that in our today's class. That is only the major task. So that is only is very important. Okay, clear? So now let us back to the derivation. Shall we start? Everybody, please respond, guys. All of you, Mr. Narayan, am I
Yes, sir.
audible? Yeah. Any
Yes,
doubt,
sir.
in small doubt also, please ask me in that. So let me consider there is a big container. All of you draw. There is a big container. So where it is filled with the gas. So there is a big container where it is filled with the gas. So it is having three axes. Everybody, what is the three axes? This axis is what? Everybody? X axis. And this axis is what?
Y-axis.
Y axis. And this axis is what? Z axis.
Z-axis.
So now let me consider this is the wall actually. So wall I will shade with the paint. So let me take, this is the wall of the container. So any one wall we are taking. So one particle. So wall it is, please note it. So totally inside n number of particles is there. How many molecules is there? Everybody? N molecules is there. And this is what we used to call it as a wall. Now, let us imagine there is a particle now, only single particle I am considering. So whose mass? See, total mass is m. Now small mass, what will take, guys? Let me take it as a what? Small m. So mass of this particle is what? Everybody? Mass of this
Small
particle is
m.
what? Small m. Okay. So now if you all observe that, so let this particle is moving with, I'll consider this particle is moving with velocity u. So let me consider it, everybody. So let me consider it is moving with velocity u. So means in the sense of it can go in three different directions. What is the three different directions? It can go in same velocity, it can go in what direction? X-axis. Same velocity, it can go in what
Y-axis,
direction?
Y-axis, Z-axis.
Y-axis, and same velocity it can go in a what direction? Everybody, Z-axis. Let, okay? Let you have to remember. Any doubt, Mr. Pradosh, in this? Clear? Yes. So we have many number of particles. We are having this particle, I assumed M, M1, M2, M3, M4, M5. Clear? All of you understand?
Yes, sir.
Okay. So now you have to make it. Now, let us consider this particle is started coming with the velocity ux and there is a wall. So let me take, we all know it's a container whose length is L. So please remember is whatever it is. Whose length is what? L and L. So now this particle is traveled L distance. This particle is traveled how much distance, everybody? L distance. So whose mass is m, and it is traveled with the velocity ux1, and finally it came and collide with the wall. So wall which is present at a L distance. Where the wall is present, everybody? Wall is present at what distance? L distance. Clear, Amma? Please respond. So now, this is what is that. Now, if you all observe that, like we are having n number of particles, doesn't matter. So now it went and collided this wall. So as I told you, kinetic theory postulates. So please respond. What is that? After it is a what collision? Elastic collision. Is it right, guys?
Yes, sir.
Please. So it is elastic collision, and elastic collision means definitely it will be what? It will stuck or it will comes back. Everybody, it will come back. So it will come back with us. It will come back with the same thing. Another thing. Just now I said Ishali said wrong. I said corrected. What is that?
Momentum.
Momentum.
Yes. Okay. All of you understand,
sir.
everybody? Yes. So it will start
Yes,
with
sir.
the same momentum, same speed. It will be come back. Means same speed means again it will travel how much distance, Rudresh? Again it will travel with the how much distance?
L.
Yes. Yes. L. Am I right or wrong?
L.
So
Yes,
after
sir.
the wall, again it will travel with the same speed. So again it will travel with the same distance. So now what is the total distance travel, everybody? What is the total distance travel?
2L.
2L. Yes or no? That is what. So please remember. So let us consider the initial momentum. Initial momentum of this one is, what is the momentum formula? Momentum is equals to mass into what?
Velocity.
Velocity. Now, initial momentum means what? Small m into, let me take initial velocity, how much ra? ux1. Is it right, guys? Please respond forward. Now, after that, again, momentum is changing or remains constant? Momentum changes or remains constant? Everybody?
Constant.
Remains constant. Why? Velocity not changes, momentum not changes, but opposite direction. So minus mux1. So if I take change in momentum is equals to, you take anything, final minus initial or initial minus final. So I'll take it. So what will happen? Mux1 minus of
0.
minus mux1. So which is equals to what? What is the change in
Zero.
momentum? Everybody?
0.
2,
2
0.
M.
What?
2 mu.
Three. What are you talking? Puriva Kadri, do you understand? So
Yes, sir. Now I
delta P
understand,
is
sir.
equals to P initial minus P final. Whatever you take P minus, both will come negative or it will come positive, whatever doesn't matter. So this is only we used to call it as a what? Delta P actually. So what do you mean by delta P? Change in what? Everybody. Change in?
Momentum.
Okay. Now, definitely from its position, it will take certain time to go and hit the wall. Okay, because it is traveled how much distance? Everybody, L distance, and again it will be come back because it's elastic nature. Elastic nature means it will back to its same position. Am I right or wrong, Mr. Narayan? Do you want to understand? Mr. Sai Karthik? Yes. So it will be back to its same position. So if it is back to its same position means, so what will happen? It will travel 2L distance. So definitely it will take, let the time taken is T. So then it will be coming back, going and coming back, distance is totally is 2L. Then the time taken for each collision, how much time it will take? Anybody? Time taken for each collision is equals to, what is the speed formula? Speed is equals to distance by time. Time is equals to distance by speed. So now what is the total distance? Distance by speed. Distance equals to what? L distance plus L distance, which is equals to 2L divided by speed is equals to mu x1. Will you all agree with me? All of you? Yes? Hope
Yes,
everybody?
sir.
Yes, sir.
So that is it. So what is the time now? L plus L. What is the time is equals to? Time of one collision. Time of one collision is equals to how much, guys? 2L divided by mu x1. Okay, wa? Pradosh, understand? Yes, please.
sir.
Then we are going to make now force. So force exerted on wall. What is the force exerted? Because force only causes what? Force causes something. What will cause us? Force per unit area we used to call something. Force per unit area, call it as
Pressure.
pressure. Force per unit area, call it as pressure. That is what you have to calculate now. So force exerted on wall is equals to something. Newton's second law of motion. Anybody? I don't says, you only says. That's what you are going to write all the chapters for final exam. Newton's second law, force exerted. Narayan will says, Pradeep Raj. Yes, please. Newton second law, Rudresh. Not F equals to ma. Second law momentum formula, tell me. What is the momentum formula? Change in momentum. What is Newton 4 second law based upon momentum. Change in momentum divided by change in what? dp by dt. Forgot it. This is only 100% always valid. Is it right or wrong?
Yes, sir. Yes, sir.
Yes, that's what. Then what you people are remembering? What is this, Pradosh? This is what is happening. When you go on, that's what. Not people, you people are not serious like 10th class. 11th class, no board exam means doesn't mean that you can relax. I'm saying you correct. 10th class, I never seen like you people like this relaxing. But 11th class, I'm not at all seeing anybody's seriousness. Newton's second law, people do not able to remember dp by dt. Then what is the use? Then substitute it, that's all. So F is equals to dp. What is the dp value? dp value, we got it, guys. 2mu x1 divided by dt value. 2l divided by ux1. Is it right, all of you? So 2 will get cancelled, ux1 will go up. So we'll get m by l ux1 into ux1. What will happen? ux1 square. So this is only the force. Anyone having any doubt, you can ask me. So force is equals to m by l ux1 square. So till here you solve it, then we'll continue the pressure. Any doubt, guys? Please let me know. All of you. Do it. No doubt, you can do it. One and Samya, be sincere, be on time, no late, please. Any problem? Understand? Everybody?
Yes, sir.
I'll come from the first. Neatly solve. Neatly solve. See, understanding concept is very important. Then only you can challenge any kind of competition questions. Make it. Clear, everybody?
Yes, sir.
Till here completed?
Yes, sir.
Yes, sir.
Now, if you completed till here, then we'll proceed. So we all knows that. Just check it. Point number 2, what we studied. We have studied that the body can go in anything. That is what the root of mean square velocity u is equals to in 3 directions. X-axis ux I cap plus, y-axis uy j cap plus, z-axis what is that? uz k cap. This is please
K cap.
and make a box. It is not under a solution. So from that, we all knows that in any direction, it can go with the same velocity. Ux equals to ua equals to uz. So that I can say u square is equals to, if I do root 3 ux square. Am I right, guys? Will you all agree with me? Please respond, all of you. Yes?
Yes, sir.
Yes. So now from that, I'll say velocity in x square is equals to 1 by 3 times of average velocity, square of average velocity. Is it okay, Rudresh? Can you say this? Yes or no?
Yes, sir.
Yeah. So now from this I will replace now we got the force formula. Force is equals to what, everybody? M by L ux1 square. That is what ux. So ux means, so let me take, this is for a particular particle, one particle. So this is for x particle. So for particle number 1, so ux1 square is equals to 1 by 3 u1 square. Will you all agree with me, everybody? If you all says, then I'll proceed. So in place of ux1 square is equals to 1 by 3 u square. So I'll write u and x square. What I can write? Anybody? In place of ux square, I can write something. Anybody? What is that? 1 by 3 u1 square. Yes or no, guys? Please respond, guys. All of you. So from that I say f is equals to 1 by 3 into m by l into u1 square. Any problem for anybody till here? Please respond. This is for what? Due to one molecule or due to many, all molecules? Due to only one molecule.
One molecule.
Yes. Due to one molecule. Make it quick. Completed? Understand? Everyone? Yes, please.
Sir.
This is for
Yes,
one
sir.
molecule. Totally we have how many molecules in gas? Everybody? We have how many molecules in gas?
N more.
N molecules. So then force due to N molecules. Force due to N molecules, which is equals to what? First molecule. 1 by 3 m by L u1 square plus 1 by 3 m by L u2 square plus, and so on, so on, so on. Finally, we'll get it. N particles is there. So 1 by 3 m by L un square. Is it right, guys?
Sir.
Yes, sir.
Yes.
Yes, sir.
Yeah. Next. So now you all can see. From this, I can take something outside. Yes, Rudresh. What else? Narayan? Involved in the class, Narayan, Pradeep.
1 by 3 m by L.
Yes. So 1 by 3 m by L, I'll take it outside. So what else remaining? Everybody.
U1 square.
U1 square plus U2 square plus U3 square plus, and so on, plus UN square. Is it right, guys? All of you? Now, in these
Sir.
situations, we have done something in mathematics. Remember, long back in rotational dynamics, divide and multiply with the n by n, both numerator and denominator, so that I can write next one. So 1 by 3 into m by l into u1 square plus u2 square plus u3 square plus, and so on, plus un square divided by n into n. Any problem?
Yes,
Pradot?
sir.
This method we have done. Anybody
Listen,
remember?
sir.
This
Yes,
whole
sir.
thing is
Yes,
equals
sir.
to something. Anybody? This whole thing is equals to something, which is equals to average root velocity. Is it right? URMS square of. Yes, guys.
Yes, sir. Yes, sir.
F net is equals to 1 by 3 into m by l into URMS square into n. So URMS means what? Everyone? Root means square velocity. Root means square velocity. That's all. So F net is equals to, we got it, 1 by 3 into m by L. This n I will bring it first into URMS square. Any problem for anybody till here? Ask me, or else finish it up to here. Any doubt? This is the total net force. Is it okay, guys?
Yes,
Yes?
sir.
Yes, sir.
Sir.
Clear? Any doubt? Complete it. Okay, everyone?
Yes, sir.
Yeah.
Yes, sir.
Next. We got force only, but actually what we have to do it? Anybody?
Pressure.
Pressure. So pressure means what is the formula? Force by
Unit area.
area is length into L, L into L. So area is equals to L into L. That's all. So pressure P is equals to force by area. So force is equals to what? 1 by 3 into M by L into N into U square. Root means square velocity divided by length. Area is equals to L into L. Now you all can see, look into the screen. Everybody 1 by 3 into M by L into N into square of root mean velocity divided by L into L. Is it okay? This all fully one. Am I right, guys? Will you all agree with me?
Yes, sir.
Yes.
Yes, sir.
That is only I want to speak. So L into L, something it is. Anybody?
Volume.
Volume. Very good, Rudresh. So RMS square divided by L into L into L, L cube. L into L into L cube is equals to something. Anyone else? Volume. Okay. So
Volume.
place it over. So that's what we'll get it. So 1 by 3 into MN U square of root mean velocities divided by V, which is equals to P. Now PV will come this side. So PV is equals to what is that, everybody? 1 by 3 into M
1
into
by
N
3
into
MN
U square. You write it. Any doubt? You have asked. Do you all understand, everyone? This is only
Yes,
what
sir.
is the formula? Any one of you? Yes, please. Kinetic.
Equation.
Kinetic.
gas equation.
I hope I have taught you very beautifully. So there is no confusion. I'm expecting everybody understand. So I want to see that. Okay, guys.
Sir.
Clear, everyone? All of
Yes,
you?
sir.
So that's what you have to remember. So this is what derivation. Hope you all clear. So now P indicates what here? P indicates pressure, V indicates volume, 1 by 3 constant, mass of one molecule, n number of molecules, average square of average mean velocity, root of mean square velocity, root of mean square velocity. Anyone having any doubt at any step, please let me know. I'll come from the first, from here. So this is, we learned already long back, nothing else I've done. Numerator and denominator I multiplied with the n. That's all. Is it okay, guys? Everybody? Any problem, Mr. Sai Gardik, Mr. Rohit?
Understood, sir.
So do it fast. Let we continue because we are going to derive now. Still many things are there. Kinetic energy. So the notes what I have sent you yesterday, you might remember kinetic energy of a gas. You have written that n into 3 by 2 RT. Do you all remember that? Everybody? Yes?
Sir. Yes,
That
sir.
we are going to make it. So keep reading next, everyone. So kinetic energy. So how much, what is the kinetic energy? We are going to calculate now. So this is also another interesting derivation. So, but you need to have a